Assalamu alaikum students, this is your teacher Muhammad Umar Khatak for the subject Project Management, and this is our 21st lecture and chapter number 5. And today the topic of our discussion is mixed organizations and project teams. Mixed organization. Divisionalization is a mean of dividing a large and monolithic organization into smaller, more flexible units. This enables the parent organization to capture some of the advantages of small, specialized organizational units while retaining some of the advantages that come with larger size. Organizing projects by product involves establishing each project as a relatively autonomous, integrated element within the organization as a whole. Such primary functions as engineering and finance are then dedicated to the interest of the product itself. Software projects are a common type of projects organized by product. Software projects often occur in clusters. Several different projects that are part of the same overall information system or application software. Pursuing such projects as a group tends to ensure that they will be compatible with one another and even increases the likelihood that they will be completed as a group. Consider a firm making lawn furniture. The firm might be divisionalized into products constructed of plastic or aluminium. Each product line would have its own specialized staff. Assume now two newly designed styles of furniture, one plastic and the other aluminium, each of which becomes a project within its respective product division. Should a new product be a combination of plastic and aluminium, the pair project form of organization will tend to forestall interdivisional battles for turf. Similarly, organizations by territory is especially attractive to national organizations whose activities are physically or geographically spread, and where the products have some geographical uniqueness such as ladies' garments. Project organization across customer divisions is typically found when the project reflects a paramount interest in the needs of different types of customers. Here, customer preferences are more substantial than either territorial or product activities. The differences between consumer and manufacturer or civilian and military are examples of such substantial differences. A special kind of project organization often found in manufacturing firms develops when projects are housed in process divisions. Such a project might concern new manufacturing methods, and the machining division might serve as the base for a project investigating new methods of removing metal. The same project might be housed in the machining division but include several people from the R&D lab and be organized as a combination of functional and matrix forms. Pure and functional projects organization may coexist in a firm. This results in the mixed form. This form is rarely observed with the purity we have depicted here, yet it is not uncommon. What is done instead is to spin off the large, successful long-run projects as subsidiaries or independent operations. Many firms nurture young, unstable, smaller projects under the wing of an existing division, then wean them to pure projects with their own identity, and finally allow the formation of a venture team or, for a larger project, venture firm within the parent company. The hybridization of the mixed form leads to flexibility. It enables the firm to meet special problems by appropriate adoption of its organizational structure. There are, however, distinct dangers involved in hybridization. Dissimilar groupings within the same accountability center tend to encourage overlap, duplication, and friction because of incompatibility of interests. Again, we have the conditions that tend to result in conflict between functional and project managers. In many ways, this organizational form is not distinguishable from matrix management, but it is typically used for small, short-run projects where the formation of a full-fledged matrix system is not justified. The matrix form shares several advantages and disadvantages of the matrix structure. But the project life is usually so short that the disease of projectitis is rarely contracted. If the number or size of the projects being staffed in this way grows, shift to a formal matrix organization naturally evolves. Though the ways of interfacing project and parent organization are many and varied, most firms adopt the matrix form as the basic method of housing projects. To this base, occasional pure, functional, and hybrid projects are added if these possesses special advantages in special cases. The managerial difficulties posed by matrix projects are more than offset by their relatively low cost and by their ability to get access to broad technical support. Choosing an organizational form. The choice of an organization form for projects is not addressed to project managers. It is addressed to senior management. Very rarely does the project manager have a choice about the way the project interfaces with the parent organization. Indeed, the project manager is rarely asked for input to interface choice. Even experienced practitioners find it difficult to explain how one should proceed when trying to choose. The choice is determined by the situation, but even so is partly intuitive. There are few accepted principles of design and no step-by-step procedures that give detailed instructions for determining what kind of a structure is needed and how it can be built. All we can do is consider the nature of the potential project, the characteristics of the various organization options, the advantages and disadvantages of each, the cultural preferences of the parent organization, and make the best compromise we can. In general, the functional form is apt to be the organizational form of choice for projects where the major focus must be on the in-depth application of technology rather than, for example, on minimizing cost, meeting a specific schedule, or achieving speedy response to change. Also, the functional form is preferred for projects that will require large capital investment in equipment or building of type normally used by the function. If the firm engages in a large number of similar projects, the pure project form of organization is preferred. The same form would generally be used for one-time, highly specific, unique tasks that require careful control and are not appropriate for a single functional area, the development of a new product line, for instance. When the project requires the integration of inputs from several function areas and involves reasonably sophisticated technology but does not require all the technological specialists to work for the project on a full-time basis. The matrix organization is the only satisfactory solution. This is particularly true when several such projects must share technical experts. But a matrix organization are complex and present difficult challenge for the project manager. If choice of project structure exists, the first problem is to determine the kind of work that must be accomplished. To do this requires an initial tentative project plan. First, identify the primary deliverables of the project. Next, list the major tasks associated with each deliverable. For each task, determine the functional unit that will probably be responsible for carrying out the task. These are the elements that must be involved in order to carry out the project. The problem is how best to bring them together, or how best to integrate their work. Additional matters to be considered are the individuals or small groups who will do their work, their personalities, the technology to be employed, the client to be served, the political relationship of the functional units involved, and the culture of the parent organization. Environmental factors inside and outside of the parent organization must also be taken into account. By understanding the various structure, the advantages and disadvantages, a firm can select the organizational structure that seems to offer the most effective and efficient choice. Since it is our objective in this chapter to provide criteria for the selection of a project organization, we shall illustrate the process with an example using the following procedure. Define the project with a statement of objective that identifies the major outcomes desired. Determine the key tasks associated with each objective and locate the units in the parent organization that serve as functional homes for these types of tasks. Arrange the key tasks by sequence and decompose them into work packages. Determine which organizational units are required to carry out the work packages and which units will work particularly closely with others. List any special characteristics or assumptions associated with projects, for example, level of technology needed, probable length and size of the project, any potential problems with the individuals who may be assigned to the work, possible political problems between different functions involved, and anything else that seems relevant, including the parent firm's previous experiences with different ways of organizing projects. In light of the above, and with full cognizance of pros and cons associated with each structural form, choose a structure. Project team. We consider the makeup of the project team, bearing in mind that different projects have vastly different staff needs. Then we take up some problems associated with staffing the team. Last, we deal with a few of the behavioral issues in managing this team. To be concrete during our discussion of project team, let us use the example of software engineering project to determine how to form a project team. Assume that the size of our hypothetical project is fairly large. In addition to the project manager, the following key team members might be needed, plus an appropriate number of systems architect, engineers, testers, clerks, and the like. This example can be applied to a construction project, a medical research project, or any of the wide variety of other types of projects. The titles of the individuals would change, but the roles played would be similar. Systems architect. The systems architect is in charge of the basic project design and development and is responsible for the functional analysis, specification, drawing, cost estimation, and documentation. Development engineer. This engineer's task is the efficient production of the product or the process the project engineer has designed, including responsibility for manufacturing engineering, design and production of code, unit testing, production scheduling, and other production tasks. Test engineer. This person is responsible for the installation, testing, and support of the product process once its engineering is complete. Contract administrator. The administrator is in charge of all the official paperwork, keeping track of standard compliance, including quality reliability, customer engineering, changes, billing, questions, complaints, legal aspects, costs, and negotiations of other matters related to contract authorizing the project. Not uncommonly, the contract administrator also serves as project historian or archivist. Project controller. The project controller keeps daily account of budgets, cost variances, labor charges, project supplies, capital equipment status, etc. The controller also makes regular reports and keeps in close touch with both the project manager and the company controller. If the administrator does not serve as historian, the controller can do so. Support Services Manager. This person is in charge of project support, subcontractors, data processing, purchasing, contract negotiation, and general management support functions. Of these top project people, It is most important that the system's architect and the project controller report directly to the project manager. This facilitates control over two of the main goals of the project: technical performance and budget. Of these top project people, it is most important that the system's architect and the project controller report directly to project manager. This facilitates control over two main goals of the project: technical performance and budget. The project manager is usually in personal control of the schedule. For a large part, all six project officials could work out of the project office and report directly to project manager. To staff the project manager works from a forecast of personnel needs over the life cycles of the project. This is done with the aid of some special charts. First, a work breakdown structure WBS is prepared to determine the exact nature of the tasks required to complete the project. The skill requirement of these tasks are assessed and like skills are aggregated to determine workforce needs. Be warned that development of WBS will often involve consultations with senior programmers and testers. The project manager needs to understand, plan for, and closely monitor the effects on current projects of these consultations. It is common for senior programmers and testers to be pulled away from their own work in order to deal with planning crises arising elsewhere in WBS. From this base, the functional department are contacted to locate individuals who can meet these needs. On occasion, certain tasks may be subcontracted. This option may be adopted because the appropriately skilled personnel are unavailable or cannot be located, or subcontractor can deliver for lower cost, or even because some special equipment required for the project is not available in-house. The need to subcontract is growing as firms downsize. If the proper people and equipment are found within the organization, however, the project manager usually must obtain their services from their home departments. Many firms insist on using local resources when they are available, in order to maintain better control over resources usage and quality. Typically, the project manager will have to negotiate with both the department head and the employee, trying to sell the employee on the challenge and excitement of working on the project and trying to convince the department head that lending the employee to the project is the department's head's best interest. There are some people who are more critical to the project's success than others and should report directly to the project manager or the project manager's deputy, often the project's architect. Senior project team members who will be having a long-term relationships with the project, those with whom the project manager will require continuous or close communication, those with rare skills necessary to project success. Remember that project manager must depend on reason when trying to convince department head to lend these valuable people to the project. The department head who sees the project as more or less glamorous source of prestige in which the department cannot share has little natural motivation to be cooperative. Once again, project success depends on the political skill of the project manager as much as on the technical skill of the team. Thus far, we have technically assumed a fairly strong matrix organization for the project in our example. In recent years, the use of weaker matrices has become more and more frequent. In many firms, when project managers are asked for the number of people who report directly to them, the answer is none. Is not uncommon. Most common of all, it seems to us, is the matrix organization with project manager or one or two key skilled contributors who may be full-time members of the project and wide variety of services or capacity supplied to the project by functional groups in the parent organization. Such structures are often found in R&D projects that are part of larger programs being carried out by a parent firm. In a pharmaceutical project, for example, one or two senior scientists and lab technicians may be assigned to the project, but the work involved in toxicity testing, efficacy testing, and writing the product insert is supplied to the project in the form of deliverables from functional units rather than people assigned directly to the project to carry out the work. Although the project manager has to bargain for fewer individuals than in the case of stronger matrices, the project manager's negotiation skills are just as critical. It is typical for the success of weak matrices projects to be dependent on the skills of few technical specialists who are assigned directly to the project. The ability of the project manager to negotiate for skilled technicians as well as for timely delivery of services from functional department is a key determinant of success. This is the end of the lecture. Thank you.